Hi, I'm Miss Hall, and in this video, we're going to practice graphing linear inequalities. So here's the method we're going to use to graph linear inequalities. We're going to first find the boundary line, and we're going to plot at least 2 points and determine what type of line to use to connect the points. So remember, there are 4 inequality symbols that we are dealing with, and I'm going to put them into 2 groups. We've got the group where the boundary can be equal to the solution and the group where it cannot. So the type of line we're going to use if it cannot be equal to the boundary line is a dotted line. And if it can be equal to the boundary line, then we use a solid line. Second step is we are going to test an ordered pair on either side of the boundary line, so on either side of the line, to see which side contains the solution set, and then we're going to shade that side. Let's go ahead and get started. So we are going to be graphing this almost identical line, but you'll see that we're using the 4 different inequality symbols to practice all variations. We need to begin by finding the boundary line. So in this case, we're going to change the inequality to an equality to graph this line. I'm going to happen to use the x-intercept, y-intercept method to find the boundary points. So I'm going to solve for the x-intercept first, which is when y equals 0. So we have x minus 0 equals 5. That means x equals 5. That means the x-intercept is 5, 0. I will plot it right here. And now I am going to find the y-intercept, and this is when x equals 0. So 0 minus y equals 5. So we have negative y equals 5. To get rid of that negative, I can divide both sides by a -1, or multiply both sides by a -1, and I get y equals -5. That means the y-intercept is 0, -5, which is right here. Okay, I only actually have to do this process once because these all have the same boundary line. So why don't I go, these 2 points are going to be part of the boundary line for all 4 graphs. Okay, but before I draw a line connecting, I need to make sure I use the right line. This symbol is less than and does not contain the equals to, so this is going to be a dotted line. This boundary is not included as part of the solution. And now we're up to part 2, which is I need to test a point on either side of the boundary line to see if this contains the solution set or this is the solution set, which side should be shaded. I like to pick points that are easy for me to quickly calculate, like 0, 0. So I'm going to test if 0, 0 is part of the solution to the original inequality. So is 0 minus 0 less than 5? 0 is less than 5. So this is part of the solution set, which would mean any point I pick up here should be part of the solution set. I'm going to guess then, and this better be right, that's a point down here is not part of the solution set. Let's go ahead and pick this one. We have 0, -10. This better not be part of the solution set, or I've made a mistake. So what is it's x, 0 minus y. Is that less than 5? So 0 minus a -10 is 10. Is 10 less than 5? No, that is not true. So this is where I'm going to shade, and often you will see this shaded as lines perpendicular to the boundary line. Okay, so that's what the graph of the first one looks like. Second one, we have less than or equal to, so this will be a solid line. And then maybe you already know which side I'm going to shade because of the first one, but I'm going to practice this skill. And so let me pick lines or points that contain a 0. So this is 0, 5. Let's see if this makes it true. So is 0 minus 5 less than or equal to 5? Is -5 less than or equal to 5? Yes, it is. So I think I'll be shading this side, but let me check something down here. I mean, this one really sticks out, but I've already used it, so let's use this one over here, which is 10 comma 0. So is 10 minus 0 less than or equal to 5? Is 10 less than or equal to 5? No, that's not true. That's not true. So I will be shading the side that is true, which is up here. Okay, it should not matter what point you pick. Any of these points up here will make the inequality true. Any of these points down here will make it not true. So we have x minus y is greater than 5. It cannot be equal, so my boundary line is dashed. Let's test, what have I tried? Let's try this one. Negative 5 comma 0. Is that a point in the solution set? So x is negative 5 minus 0. Is that greater than 5? That is negative 5 is greater than 5. That is not true. Nope. So something down here better be part of the solution set. I'll try this one again. This is 0 comma negative 10. Is this true? So we have 0 minus negative 10. Is that greater than 5? Well, that is 10. And 10 is greater than 5. So we are going to shade everything underneath the boundary line. And final one, we have greater than or equal to, so our boundary line is going to be solid. You could test this out by checking a point on the boundary line and making sure it made it true. That's not going to help me figure out which side to shade, so I'm not going to do that. What have I not used here? I have not used, let's do this one. Negative 10 comma 0. Is that true? Negative 10 minus 0 is greater than or equal to 5. And it is negative 10 is greater than or equal to 5. That is not true. So let's try, well, I'll go back to one I've done before. 10, 0. Well, look, I chose one on either side. Works just fine. So is 10 minus 0 greater than or equal to 5? Is 10 greater than or equal to 5? That is true. So I am going to shade everything on that side that includes that point. Okay, yeah, I guess that makes sense. I did all 4. So you see each boundary line twice and each shaded twice. Now it's time for you to try one. Unpause the video when you're ready to check your answer. The line in each graph represents y equals 2x. Which graph represents 2x is greater than y? So the greater than symbol means it's going to be a dashed line that the boundary is not included. So I know I can get rid of B and I can get rid of D. Now between A and C, let me pick a point that is shaded in A and see if it is true. So here's a point 0 comma 6. And the inequality is 2x is greater than y. So is 2 times 0 greater than 6? Is 0 greater than 6? No, it most definitely is not. So that part should not be shaded. So this should not be shaded. Let's check down here then. I really think it's this. Let me try a point. Here we go, is the point 4 comma 0. The inequality is 2x is greater than y. Is 2 times x, so 2 times 4 greater than y, which is 0. Is 8 greater than 0? Yes, it is. This one was not true. And so this should be shaded, which means the correct choice is C.